Prakash, I see a hand raised. So
okay, wait. Okay. Sagar, can you make a co-host to him, like for Prakash as well as for Ashish?
Hi.
Hi, Prakash.
Wait, Ashish not is present.
Let me check. I will check with Ashish.
Wait, Ashish not is present.
Hello, Ashish.
Yes, hi Jameer.
Okay, yeah. Yeah, I guess we can start. Saikesh, yeah?
Yes, I see him in the list somewhere.
Okay. So shall we start?
Yeah, I guess so.
Okay. Hello, everyone. Welcome to this experiment session. So we are going to we are going to do few experiments using radio waves. So hi, myself Jameer. So along with me, my colleagues are there: Ashish, Avinash, Deshpande, Prakash. So who are there? So just a second, I will share my screen. So is the screen visible?
Yes, Jameer.
Yeah.
Okay, thanks. We'll see like two radio experiments here, which are very simple and can be done by using with the available resources at homes. So nowadays, everyone has cell phones, everyone have like laptops, along with the Wi-Fi module, router, and other similar devices like tablets and all. So we have designed like few experiments. Among them, we are going to see two experiments here by using simple devices like cell phone, smartphone, and laptops. How can we see how this radio waves plays in our daily lives, and how we can see some of the physical phenomena, like how it is acting, the inverse square law, and how a reflector will act. So we'll see these two experiments here. So we'll go one by one. So we are going to do two experiments. So one is the verifying the inverse square law using Wi-Fi signal, and the second experiment is effect of putting a reflector at the back of the antenna. So here we are using a cell phone antenna, and we are putting a back metal reflector. A metal reflector can be any kind of a reflector, which can be easily made at home, or maybe they are ready-made available. So we are going to see during the experiments while explaining it. So we'll go for the first experiment. So we'll see the first experiment verifying the inverse square law using Wi-Fi signal. So you can see in this image like how the intensity of a source or a radiator is gradually decreasing when you move away from the source or the radiator. So we have seen this. We have also listened to the Professor Dipanjan in his first lecture in radiative process. He already explained this. So we are going to verify this. We'll see how it's we'll see the behavior of any radiator. So whether it's like radio waves, whether they are any electromagnetic wave or gravitational wave or sound waves, they follow this inverse square law. So we'll see and we'll verify it. So here's a simple setup. Okay, we need a radiator for this. So here we are using a cell phone as a radiator, so or as a transmitter. So we'll take a cell phone and we'll put a hotspot. We'll switch on the hotspot on it, and we'll connect to the laptop. So laptop will act as a receiver here. So and we'll keep a distance apart. We should not keep very close to the transmitter. We'll keep at a certain distance, and we'll start taking observations. And after that, slowly we'll move a little bit away from the transmitter and see how the radiation is falling down. The radiation is the flux is reducing. So we'll see a simple setup here. So we need to keep in mind few things here. So if you see in this image, can you see my cursor? I guess. Okay.
Yes.
Yeah. So here is the transmitter, so which is a cell phone. We purposely kept at a certain height from the ground. So we should avoid keeping on the ground because there are a lot of reflections from the ground. So that's why we need to keep at a certain height. We have to use a non-metal thing here. So you can see we have used cardboard boxes as well as we have used plastic chairs, and we have kept if you don't have laptop or any other receiving device, even you can use cell phones, tab or laptop, anything. So purposely we haven't kept anything here on the receiver side. You can use anything. And after this setup, so once you switch on your hotspot here and you connect to the receiver, so make sure that you need to keep certain distance between these two devices. So once you connect it and measure the received power on the receiver side, so which will be in decibel in dB, and you can measure it. And after certain, and we have to keep little bit time. So it's not like that we take observation after interval of few seconds. At least we need to wait for like half minute to a minute, then take a observation or reading, and after settling down, and you can move after after a certain time, you can move a little bit away. You can move a little bit sorry,
Jyotir has some question.
yeah, maybe he can unmute himself and ask. Hello, Jyotirma? Sagar, can you unmute him?
Yeah, I'm asking him to unmute. Yeah, Jyotirma, you can unmute yourself and ask the question.
I like to ask sometimes later. Means first I listen the full experiment, then I will ask.
Yeah, because your hand was raised, we didn't know whether you had an urgent question. Okay, thanks.
Yeah, so after a certain time, you can move a little bit away from the transmitter. Again, take the reading. Likewise, you can go for a while, and it will be better if you do this experiment in open space or in open ground, so that we can avoid reflection from the ground or any other metal things which are situated near the setup. So even we have to make sure that we should not interfere in between, or we should not move here and there during the experiment. So these are some precaution. We have already like mentioned this in our slides as well as in our write-up. So I hope you have gone through the write-ups. If not, then maybe after this lecture or the session, you can go through it. So what are the hardware we need for this experiment? We need a transmitter or a radiator, which is a smartphone, which is like with the hotspot. I guess like all the smartphone have the hotspot built in it, and at the receiver side, we need either laptop, smartphone, or tab, or similar devices, and we need a measuring tape to measure the distance between the uh, like transmitter as well as the receiver. And we have to make sure that we need to measure precisely the measurement. And before that, we need to know like a few of the things, like what kind of smartphone you're using, and where the antenna is located in the smartphone. A physical location of antenna is very crucial here in few of the experiment. Like in next experiment, while you're performing, you need to know the physical location of the antenna which is there in your smartphone as well as in the laptop. So here's the procedure. So ensure your router or the Wi-Fi hotspot is on the like smartphone. And before that, we have to make sure that there should not be any data connection is on. So we need to like off that. If there is any data connection in the data connection is connected in your smartphone, it will be better to keep your smartphone on aeroplane mode while performing this experiment, and connect your receiving device, either laptop or anything, to the transmitter. So then you need to, yeah, I already mentioned the data connection or internet connection need to be off. It will be always better to keep on a flight mode or aeroplane mode, and start measuring the distance. Okay, like at least for 10 to 8 to 10 different distance. Okay, it will be better if you change the distance in a very symmetric way, and start. You can start maybe as close as from 5 centimeter, and you can go for a few meters, and more the readings, more like it will be better for a good result and to interpret it. So, and after that, you can plot the graph, the signal strength versus the distance. So you need to plot in a log scale. So then these are the tips. Few of the tips we are like mentioning here while performing the experiment. Yeah, as I already mentioned, please find the physical location of an Wi-Fi antenna which is present in your device, as well as it will be like you need to charge fully before you're performing the experiment. So both your cell phone as well as laptop you need to charge, and the detecting might take few seconds or maybe like half a minute to settle down the reading, and you have to make sure that it's not fluctuating a lot. And maybe like you can see if you have connected to the data, the fluctuations are more. When you're like disconnecting the data, or if you keep on a flight mode, the fluctuation will be very less. And avoid taking observation after certain distance when you start observing uh, beyond 80 dB or 90 dB. So at that point the error will be more, or because the distance is long and it's not that sensitive to the smallest variation in the flux. So if you're getting more than 80 dB or 90 dB, stop taking observation at that time. So these are the few things, and make sure the data connection is off. These are the already we have mentioned. Yeah. So we need to see, like in first or second experiment, it will be helpful to know that at what frequency the connection is operating, or the data connect the cell phone as well as the hotspot are connected, whether it's 2.4 gigahertz or the 5 gigahertz, we need to see. So they operate at these two frequency, 2.4 and 5 gigahertz, with a certain bandwidth. So avoid moving setup when you start taking like measurement. So the setup need to be like from start to end. You should not disturb the setup. Even the slightest will like introduce some error. So yeah, here you can take. This is how you're going to take observation. You can start from 5 centimeter, and you can go for like few meters, and you can take reading so. For example, we have mentioned here at 5 centimeter you're getting minus 10 dB. So this reading will be in minus, so it will not be in positive. So you can see how it's varying, and beyond 80 dB, so we suggest that stop taking reading, and you can stop there. And after plotting, you will get this kind of graph. So you can see how gradually it's dropping with respect to the distance. Yeah, so I will stop here, and next experiment will be discussed by Ashish. Ashish? Desh, you want to say something, or if I have missed anything?
Yeah. In case there is any confusion about moving the setup, of course, the setup has to be moved in terms of the measuring equipment. It's just that you should not move around it to block and stuff like that. That's what I think Jameer meant.
Yeah. Ashish?
Jameer, maybe you can take a few questions.
Okay, so yeah, Jyotirma, you had doubt, right? So maybe you can ask now.
Yes. Okay. Am I audible?
Yeah, we can hear you.
Yes. Actually, I was tried this experiment. For that, I used the router is the transmitter, and I was using mobile as my mobile cell phone is a receiver. But I have not found in my mobile any Wi-Fi signal strength meter, which will give in dBm.
Okay, so we are explaining that about the tools and software. So after this explanation about the experiment,
can I download some app from the Play Store?
Wi-Fi yeah, so Wi-Fi Analyzer is the one of the apps, so which is freely available on either App Store or Google Store. So you can download meanwhile, and I guess it will take few minutes.
Then I was taking a reading means after 1 meter distance apart, 1 meter, then 2 meter, then 3 meter, like this.
Then maybe you can reduce distance little bit, like more, like maybe half a meter, so you can see the slightest change.
Yes,
and more the sample.
Yes, sir. Initially it was suppose minus 15 dBm, then like minus 25, minus 30, minus 40. After that, it again means it again means reduces, means like minus 50.
So you didn't see any change after that.
Huh?
So maybe you can see sometime it will take little bit time to like settle down or the change in the reading. That could be one possibility. And second,
when I coming to nearby the windows, then other signal may come to my mobile.
No, once you select one device, so that will be locked to that. So I don't think any other device will be like interfere until unless it will be better, as we mentioned. So instead of connecting to router, so if you connect to the mobile hotspot, it will be better, because if you're connecting to the router, make sure that your internet is off. So you have to disconnect your LAN cable maybe. So that is another suggestion we can mention here, so that you don't see any fluctuation when we are connected to the data. So the power may change little bit. You're getting it?
It means you are telling that I will use a mobile hotspot as a transmitter.
Yeah, that will be better. That we are like.
Yeah, even the router will work.
Yeah, router will work.
Disconnect it from the external world so that there is no data transfer, and it will simply be radiating internally, locally.
That how I will do that?
You have to like disconnect the LAN cable from the router.
There is no, it is Wi-Fi router.
Yeah, it's a Wi-Fi router. There is a LAN connection which is coming from like internet connection is there, right? So first you need to disconnect that and switch on the router and connect that router to your cell phone, and you'll see there are like less disturbance in your reading. And I guess
I can
it
use
should
the
go
one mobile hotspot is a transmitter, and another mobile I can receive the.
As a you can use as a like receiver, another mobile. Even if you're using two cell phones or smartphones, it's fine.
Thank you.
Yeah, the details of which software, how to equip your equipment with measurement facility, that will be described soon after the experiment 2 will be described.
So once we are done with this, then we'll describe this about the software installation, how to use it.
It's using router to do this, carry out the second experiment will be difficult because to keep one reflector behind the router, then there will be no space, some problem will be there. So better to use cell phone. Then you can place the reflector behind the source, behind the transmitter easily.
Okay, there is a hand raised by Abhijit. You can unmute yourself, Abhijit.
Good afternoon, sir.
Yes, please go on.
Sir, basically, when the PDF was shared in the PB workspace, I actually tried the experiment. I have installed I think there was a link of Tumbler app in the document itself. So I installed that app and I used the mobile device as the transmitter. Then what happened, sir? When I tried recording the signal, so even the distance was constant, and my data connection was also off. So it kept fluctuating actually. The distance, the signal was kept fluctuating. Maybe there was a constant line, and then there is a drop, and then a constant line. So which part of that specific limit that we are seeing in the graph we should take as the reading, because it was fluctuating a lot.
Yeah, it depends on what whether you are seeing high level of signal in the beginning when you are close enough. Depends on which particular experiment you are doing, and as long as you are seeing substantial signal, at least the connection was established. And then I suppose you must have seen the reduction as well.
Yes, sir.
And then when the level goes very much below what can be measured accurately, which is about minus 80 dBm or minus 90 dBm of that order, then you cannot rely on the accuracy of the measurements, because it's the noise level is comparable. So in any case, I think a stable measurement will require you waiting for maybe 10 seconds or something, or a good fraction of a minute, to see a settled value which you can note down. And this is, of course, assuming there is no data traffic. That can cause a lot of fluctuation.
Yes, sir. So basically, I have to take only that reading where the graph was stable for most of the time. So I should take that reading, sir, right?
Yes. I mean, ideally, if there are no other data transmissions and so on, it will be generally stable during that entire period, okay, with small fluctuation. But it's always good to give it some time because of the change distance and for it to, the meter to show you a more stable value.
Okay, thank you, sir.
Of course, there will be small errors in the measurements you will do, but they will be, they're going to be presumably small compared to the values that you will be comparing from one distance to another distance.
Yes. Thank you, sir.
Hi. So coming to the second experiment. Uh, so the second experiment is to see the effect of putting a reflector behind the antenna. So here we assume that your mobile phone is the transmitter, and you are using a metallic reflector uh, behind this cell phone, and observing the effects of this arrangement. Jameer, next slide. Yeah, so in this image, you can see that there is an antenna. This is a dipole antenna. There is a rectangular reflector, and what this metallic reflector will do, it will reflect the waves that are falling on the surface. And ideally, you can imagine this as a creation of an image of the antenna due to this metallic plane. So the depending on the position of this reflector, you will see the pattern emerging from this setup. So we are looking in the z direction as shown in the graph, and if we place the antenna, if we place the reflector at lambda by 4 distance from your transmitter, then we see that the power is maximum in the forward direction and it falls off as we go around. So the experiment is exploring this phenomenon along with some other effects. So Jameer, next slide. Yeah, so this is the setup that we are aiming for. So your transmitter is the mobile phone. You have a reflector on the left hand side, and on the right hand side there is a receiver, which can be a laptop or a mobile phone. And so we are keeping the reflector at some particular distance from this mobile phone, and the goal of the experiment is to vary this distance and see the effect of that variation on the received power. So other distances and heights should be maintained as they are throughout the experiment. The only variable is the distance between the transmitting mobile phone and the reflector. So, for example, you should not change the distance between the mobile phone and the laptop, or you should not change the heights at which they are kept. And you will see that depending on the position of this reflector, the power is changing. For this experiment, it is essential to know at what frequency you are operating. So when we discuss the software installation and those topics, we will see how to check which band we are connected to, whether it is the 2.4 gigahertz band or the 5 gigahertz band. Next slide, Jameer. Yeah, again, the hardware setup is very similar to the first experiment. The only change is the reflecting plate, the metallic plate. We You can use any metallic plate available to you, which is significantly larger than the mobile phone, or it can be a household plate with a flat surface, metallic plate. Next slide, Jameer. So here are two examples. On the left-hand side, you can see the mobile phone is kept in a non-metallic holder, and the reflecting surface is created with a aluminum foil which is wrapped on a cardboard sheet. So if you have an aluminum foil available at your place, then you can wrap it on a cardboard or any other surface like that, and that will create your reflecting surface. On the right hand side, you can see the reflecting surface is a copper plate, and in fact, you can use any household metallic plate that is available to you. If they are rectangular or circular, you can use both of them and try to see the effect. which gives a different. I mean, what are the differences between the results? Next slide, Jami. Yeah, so procedure is similar to the previous experiment. Most of it is similar. So we keep the mobile phones and laptops at some height and at a distance 1 meter or more, and we place the mobile phone in vertical orientation, and we keep the reflecting plate parallel to the mobile phone, so as to get the maximum effect. And you should vary the distance slowly at very small intervals, maybe let's say 1 centimeter interval, so that you can see the change in the received power clearly as a function of this distance between the transmitter and the reflector. Next slide, Jami. This is a sample observation table. You can change the distance of the reflector by centimeter and note down the received power, corresponding received powers. Next slide. Here is a sample result where the distance is changed, the reflector distance is changed, and we see some variation in power. There are some peaks and troughs depending on the position of the reflector. Next slide. Yeah, so this was experiment 2. So coming to the software setup part, this is in fact more crucial. So depending on what type of devices are available to you and the operating systems, there are 4 possibilities here. So Wireshark is all these are open source softwares. You can download them. The links for this procedure and where to download all these things are given to you. So Wireshark can operate on all 3 operating systems: Mac OS, Windows, and Linux. We recommend Mac OS for Wireshark, as Windows and Linux have they might face some problems due to drivers. So, Jameer, I can share my screen.
I will stop my screen share.
Yeah. Yes, is my screen visible?
Yes, Ashish.
Yes. So in Wireshark, there are actually, so the installation procedure is pretty straightforward. You just have to copy and paste the Wireshark file on Mac OS, and on Windows and Linux. On Linux, there is an installation command. If you are operating, if you want to operate Wireshark on Linux, then we can tell you the procedure. Or on Windows, it is again simple. We just have to click on the setup file. So this is the, after installation, this is the window that you will see once you open Wireshark. And you can see that if you are able to see my cursor, you can see on right hand side there is a drop down menu where you have various types of connections that are available. So we are interested in the wireless connection. So I select the wireless connection and I see Wi-Fi EN0. So this is the wireless connection that I am connected to. So all this procedure is in fact given in the documents that we have put up in the links. So this is just a demonstration to show how to operate the software. This next step is actually very important for Wireshark. We go to this capture options tab, we click there, and we should see in front of Wi-Fi EN0 we should see monitor mode should be ticked. Now this is a limitation of Wireshark. It operates only with certain hardwares. There are specific brands of hardwares in every laptop. They are different. Some are supported by Wireshark, some are not supported. So if you are able to click this monitor mode, then if this is available to you, then Wireshark is you can use Wireshark. So monitor mode is very necessary when you are using this software. And then we click on start, and you can see that there are all the packets that are crossing your device appear here in form of a list. And if you have multiple connections around you, you may be actually seeing multiple packets coming from multiple devices. If there are multiple routers or hotspots around you. Now we are interested in the device that we are connected to, let's say your mobile phone or the router. So here at my place, I have a router, and you can check the SSID on the right hand side of some of the packets. They will show SSID, and this is the name of the router, and it is connected to 5 gigahertz band. So I can select this packet. There is some information on this bottom panel. We are basically interested in only packets coming from this device. So to do that, what we can do is we can expand this IEEE 802.11 beacon frame, this section. And here you will see source address. So we are interested packets coming from only this source. So I right click on this option, this source address, and I go to apply filter, and I click on selected. That means the filter will be applied to the selected address. Now what has happened is that I am seeing only the packets coming from this device. So now we are ready for our experiment. You can see there is power indicator here. We can actually plot this. We can go to statistics and click on IO graphs. And you should see a window something like this. And you may not see anything in the beginning. So what you need to do is you need to actually define some parameters for this plot. So in y-axis, we want to see the average y field. So we choose that parameter, and we have to give a command here, which is basically telling us that telling the software that we want to see the signal power. So the command for that is wlan_radio dot signal, and you can see some options here. We want to see signal in dBm. So I click that and I press enter. Now the plot has changed, and what you are looking at is the power coming from the router to your device, and the y-axis is in dBm. The x-axis is in times. We are getting the signal every 1 second interval, or every time a packet is received from that device, from the transmitter. So you can see on y-axis there is a variation of about 2 dBm. Since now I'm connected to the data, we see more fluctuations. If I disconnect from data, this fluctuation will go down, and then you can start your observations. You can also save this data on the bottom right corner. You can see the save as option. I click on that. I choose the save location, and I save as .csv file. So that will have information related to the all the information that we collect on this plot. So I have already saved such a file, and I can show you. So this is the file that you get. You can note down the distances and the corresponding powers. And this is the plot. This was recorded earlier. So here I have changed the distance, and I can see a drop in power. I have again come close to the router. I see increase, and then again I go away and I see decrease in power. And there are some slight spikes in between. You can ignore those. And yeah, so basically this is the procedure to use Wireshark. I think we can go to the next software. Jameer?
Yeah, so can you stop sharing your screen?
Yeah.
Yeah, we'll see how to install Vistambler on Windows OS. So start sharing the screen. So the installation process is very simple. So it's just like .exe file and package you can directly install. So once you install this, so you can open the software. So this is the how basically it look like, and there are a few things we need to keep in mind before installing the software. So if you have any like antivirus, so make sure that it should not like take it as a Trojan. So please disable your make sure that you disable your firewall filter, and it should be able to install. So make sure that it should be exceptional for this software, so that you should disable. And for the Mac OS, before installing the Wireshark, make sure that you have installed the Xcode. Without Xcode, that won't work. So Xcode is very important for the Mac, and if you have like antivirus installed in your Windows system, so disable for this application. Yeah, once you install this, so I will switch on my hotspot on cell phone. So maybe it should appear here. So you can scan APS. You can click on the scan APS. Yeah, now I can see it has detected a device here, which is Poco F1, the cell phone which I'm using here. So you can select this. And after that, you can go for like filter. So I've already added filter. So if you haven't added, then you can go for add and remove filter. So like you can name here like whatever you want, your name or device name, and SSD. Make sure that SSID, whatever is written here, like for example, Poco F1, you have to write here Poco F1 and click OK. So I have already like added a filter here, like for my device. So I don't need to add more here. So I just told you how to install or how to add a filter here. So once you have done that, maybe you can go in a view and like you select this. So yeah, so you can see there are other devices which is detected here, router. So and then we'll go for a graph. So if you want to see how it's look like, yeah. So this is the graph. There are two graphs basically. So this is one type of graph. There is another type of graph here. So you can see the two graphs, like it's showing the power with respect to the time. So if I slowly move a little bit away from the receiving device and the transmitter, so you can see there is a drop or there is a change in the graph. So it will take little time. I have switched on the data. Actually, I can't switch off here because it is running on a like Wi-Fi. I'm using this cell phone. I can't switch on this. So you can see there is a slight dip in the power, and there are few fluctuations. And you can see same thing here in one graph. I'm also moving a little bit, so you can see there are spikes and disturbance in the observations. Yeah, this is how it looked like. So like once you are done with it, if you want to save, so you can simply go on a file and export it, export to CVS format. And if you want to save all the APs, you can do that, but we will suggest only go for the filtered APs. So we have filtered for the cell phone which we have selected. So you can select this Deshpande detail CSV and you can save it. So now it has saved the file, which is saved in this location. So simply like you can go into that location and see.
There is a hand raised. I will unmute.
Okay.
Ask.
Yeah, this is the saved file with like all the information. So here is the RSSI. So simply you need to select this and
Hello, sir.
Yeah, if you have an immediate question, please go ahead.
Sir, I have one question. Like, we are using phone as a transmitter here, right? So, sir, if we will put it on a flight mode, then how we have to connect it with the receiver then, sir?
you
Because
need to switch on the hotspot.
but suppose I'm using iPhone, then I have to
Yeah.
on mobile data. Then only we can on the hotspot, right? So, sir, but you said that we don't even have to on the mobile data. Like, we have to keep it off. So, sir, by keeping mobile data off, how can I on my hotspot and how can I connect it with my laptop?
Yeah, in this situation, you have to deal with the data packets you're receiving because Sendful won't allow you active hotspot without the data package on, right? So at
Yes,
that
sir.
time you have to deal with it. Otherwise, there should be some way, but we need to find.
Yeah, some
Okay.
phones might allow. I don't know about the iPhones, but some phones will allow you to have a hotspot on, even if you are in the flight mode.
Oh, okay, sir. So,
Yeah,
like, we don't
Android
have
phones
to.
allow it.
Okay, so we don't have to put our mobile data on while we are putting a hotspot on in Android phone.
Yes.
Yeah, the understanding. Yeah.
Okay, okay. Thank you, sir.
Yeah, so this is how it looked like when you plot the graph. So this is an example. So yeah, if you take more samples, so it will be like better. So this is about the Tumbler, which runs on Windows OS. So if you have any doubts, you can ask. Otherwise, we'll go for the Linux. So any comment, Ashish, on it? You want to add something, Ashish?
Hello.
Yeah,
Yeah.
Yes. I am seeing here, suppose in this software, four sources. One active source, four active sources. So how I will select some particular source? How I select? Suppose when I open this and view, then I have seen so many sources, so many signals.
So you need to select that when you are observing like many sources.
Just I will click on that.
We need to add
Suppose
filter,
1, 2,
right?
3, 4 like that.
Yeah, so we need to add filter. So that's why we like if you're using Windows OS, if you have a Tumbler, so you can go for a filter and add remove. So when you add a filter, so it will select only that device. It won't select any other device.
Add means suppose what I have to do, how will add?
So you have to add a filter. So like you can add a filter here. For example, this is SSD or something. And here I have 3 devices. So you can see on the back screen. So I can say Aurora. So that is.
Suppose when I click on some signal, it becomes blue row. So that means it is selected.
Which software you are using?
Vistun block.
Okay.
This one, Vistun block. Saying. So in the below, I am seeing there's actually 1, 2, 3, 4 like that, 5, 6, 7, 8, 9 this. So I like to see suppose a particular signal means my mobile hotspot. So I will click on that. That means that graph is coming.
Yes.
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 So whichever one is blue.
So then,
yeah.
Yes. So then what is the function of filtering? Means it is filtered. Means
that,
which is shown.
It helps during the. It helps actually if you apply a filter, you will not see the other connections. So and also it helps during the save procedure. So when you save.
How I will filter this? I will apply filter.
So once you have created the filter, you can just go to view.
You have to go to view filters
and just click on that
add
filter.
Yeah, so
click on.
If you want to add or remove filter, you need to click on this. Otherwise, I have made already 2 filters for 2 devices. I have to click on this, so it will select only one device. Before that, there were 3 devices listed here, and now it has selected only one device, which is Poco F1 cell phone. You got it?
Here, when I click the add filter, then one window is coming. Here everything is white, means filter name, filter description, color
so
white.
Basically, you should get something like this, right? Can you see your screen?
Ashish, you can show an example, or Jameer,
yes,
show an example of the edit of already existing entries.
Sure.
Okay, you can edit the already existing one, and that might demonstrate where the entries are kept or made.
I will remove this.
No, you can just edit that, even the existing one.
Yeah, first you need to go in view and then add or remove filter. So once you click it, okay, add filter here. Okay, so I have 3 devices here, around me. So if I want to connect to one device, which is Poco F1, so I will write my name here, which is device name. And I have in SSID, we have to write same whatever you're observing here. Okay, so here Poco F1. So Poco F1. I just have to say okay. Okay. Now again go in a view block, and you see there is a filter here which I have created. Then I have to select Jameer. So it will select only that device. Can you see here?
Yes.
It has selected only that device. Click on it and go on a filter again. Graph, and you're observing graph 1 already here. If you select graph 2, it will show this graph. So whichever graph you want to observe, you can view from here, graph 1 or 2.
So what is this graph 1 and graph 2? What is the difference of this?
So there are 2 different type of graphs. That's it.
I think they are averaged differently. This one that you see with less noise is probably an average over a certain duration, which gives a more stable value. Then fastly sampled values are displayed in the other plot.
So right now the graph is not varying because here it's not active. You can see there is a dead here because it's disconnected. For a while it was active, I switch on the hotspot, but I haven't connected. So again you can connect it, and then it will become active, and you can see there is a variation in the graph. So this is simple. Hope this is clear to you, Jyotirmay.
Yes, it's clear. Thank you.
Yeah. Okay, so maybe we can go for the Linux version. Prakash?
Yeah, sure. Thanks. Okay, let me just share my screen. I think right now you should be able to view. Okay, good. You should be able to view the terminal. In Linux, it's pretty straightforward when it comes to figuring out the strength of the Wi-Fi signal that your laptop is connected to. It is conveniently stored in a temporary local file called wireless, which has this particular path /proc/net, and the name of the file is wireless. So to simply just get the instantaneous value of the strength of the Wi-Fi, all you have to do is use a command to read that file, like so. And what you'll see is the headers, and then there'll be a device identifier. Why it's cutting a bit. And then under quality, there'll be this level, which will give you in MDB or dBm the strength of the signal. And that is what you need to access. So you can imagine you can always use a command to read the value. Let's say you use awk, and at any instant you can print that value. You can write a bash script. You can list these values at regular intervals, and that's pretty much it. You're reading that file, and the last three values have been same, but eventually it changes. Right now everything is static, so probably it's very stable. But you'll see that it does change over time eventually. So fundamentally, this is what Linux has, and it's straightforward to access the value. If either you can write a code in bash and then read it like so in a loop, and it will just list it down. There might be other ways to get an instantaneous value and plot it using maybe GNU plot. You would require some clever coding for that, perhaps. One thing I explored is trying to do that with Python. So the only tricky part would be to install the various packages, and if you do not have much experience with Python, to get used to that. Other than that, it should be straightforward. Let me now share the Python code.
So this, of course, Prakash, presumes that you have already established a wireless connection with the device, right?
Yes.
Otherwise, it may not respond with a particular value.
Right. So if let's say you're connected to Ethernet, or you're connected through USB to your mobile phone, USB tether, it's not going to show up. Your Wi-Fi needs to be on and coupled to a signal. Only then this file will have valid values. Otherwise, it won't.
Yeah, thanks.
So, yeah, thanks for that. So now you should be able to see the Python code, which was also shared with you guys in the description. Now this is a code which you can either open it on Colab, which is this Google's Jupyter Notebook service, or you can locally open it as you would any other Python notebook that you regularly use for coding. So either way, you have to run this locally. Even though here I'm showing you an example where I'm opening it on Colab, and you can open it in Colab too. The connection needs to be a local one, not to a Google server. So there is an option for that. If you see on the right-hand side top, there's a connect button. Next to that, there's a drop-down window, button. And if you click on that, it has a hosted runtime, which connects to a Google server, or a local runtime, which is what we seek. The reason for that is because we want to access a local file, and we just want to read it and plot it. So once you try to connect it, this is what a modal will come up, where it will give you instructions as to how to connect to a local runtime for running Jupyter on Colab. So if you click on the first link over there, it will tell you what all needs to be installed beforehand. For instance, these extensions using pip, and then it will tell you how to start it. It will give you the command. The important part is the port number. And you essentially have to install these extensions and then run this command. I'll quickly show you that as well. Okay, so now we are back to the terminal. And I've essentially copy pasted the same command. Sometimes you might have an issue where the default port is not available for the 8888, in which case you can choose alternative like I think 8000, and there are a few more port numbers that should be generally available. 8000 is the alternative that you can use, but you can try with the default first. And once you press enter, you'll see that there are two links that are given to access the notebook. So you'll have to copy the one with the local host. And that is what is described in that in those instructions on Google as well. So you just copy this full link with the local host. And let me switch back. And what you have to do is you have to paste that, whatever you copied the link over here. And then you connect. And you'll see on the top right that it's now connected to a local runtime. And now it has access to the files that are stored on the computer. One other thing, even before you run this, start up this Jupyter notebook, is that you need a plotting library called Jupyter Plot, specifically progress plot inside that. But if you just install Jupyter Plot, it should have that. Other than that, Pandas, NumPy, and Matplotlib, these are pretty standard libraries. Seaborn is optional. So once you have that, you just run these cells one by one. The first one just imports. The third one is where you give the location of your file and you open the file. There are two functions that I've defined. The first one is CDBM, which tries to get just that number that we are after, the Wi-Fi signal strength from that file. So whenever we call this function, it's going to read that file. It's going to go to a particular location that is done using seek, and then it's going to read that line, and it will take just the number that we are interested in, and it will convert to float and return it. So you just get one float value back whenever you call this function. And the next step is just another function where it's going to do this over and over for a specified number of steps and specified time interval between each step. That is what this does. And you can see it takes two variables, step and steps. Step is the step size. You can call it like so here. Most of it is pretty well documented. You can read and it should be clear to you. The first one is the time interval in seconds. So this one, for instance, examples every half a second, you can change this. I don't know what the default value is, how often the file, the original file itself is updated. One can probably check that using trying smaller and smaller values, but it's definitely not 0.5, it's smaller than that. And the number of steps, in this case, let's take a smaller value like 40. And you can change these two values, or you can use the default ones. And as you press enter, okay, I didn't run the previous. Now it. So this is what the progress plot library does. It allows you to, plot in increments rather than using a static data set and plotting it at once. It will allow for you to use the same plot and then update the values and update the plot itself. So that is what is done over here. On the y-axis, the values are in dpm. It's cutting out a bit, but it's minus 58, 50, minus 59. Must be just the font size issue here. So you can do that for any length, any time step, and you can get a plot just like any software that you use, like Wi-Fi. if you're plotting, if you're installing JupyterPlot for the first time now, sometime now, the new version has a bug where if it has a dependency called LCurve library, where if you're plotting the latest version, it might have an error in the way how the functions are defined inside. So if you do see this error where it says there's a value error and this variable facet underscore config must be a string, all you have to do is go back to the terminal and revert to a older version of the library LCurve, which you do by just running these two commands. Otherwise, it should work just fine. The function over here also does another thing other than plotting. It also saves the values as a data frame, as you can see over here. The first 10 values are just sampled over here, but this data frame called sampled.f contains all the values that is plotted over here. So this is something you can use to run whatever analysis that you want to. So the same data frame can be plotted again now as a static graph, which will be the same as this one that you saw in real time. And essentially, it will give you more freedom as to what you want to do. Especially these codes, you can extend it. Obviously, you can write your own module according to the way you are running the experiment and play around with it, change it however you want. So I think if any problem you're facing, that would be in running the Jupyter or any of the library files, if at all. If you do so to raise an issue, either using the form that is given for questions or in that page where this information is shared. Refresher course participants, you should be able to do it much more easily using the forum on Manur, where we will be able to solve these questions, solve your problems, or any of your fellow members participants should also be able to help you out with it. But that's pretty much it. All we have to do is, run this collab notebook on a local runtime and run these cells, which should be straightforward. Any questions? Anybody tried it, and if they had any issues or got it fine, or got it working fine? Okay, if nothing so far, you can, try it once and then get in touch with us. Over to you, Jameer.
Okay. Yeah. Thank you, Prakash. So we'll go for the next thing. So at the end, we'll see like how many of them are using Windows OS or Windows platform, Mac platform, or other platform. So based on that, if we get query, then we can sort it out. We'll see how to install app on our Android and how to use it. Ashish?
Yeah. So finally coming to the Android phones, those who have Android phones, they can use this method of measuring signal strengths. Yes, so is my screen visible?
Yes, Ashish.
Yeah, so on Android phone, actually, there are several applications which will show you the signal strength of the channel that you are connected to. But we found that this is one very versatile app, and it allows you to filter things, which most of the applications don't allow. So on this page, you can see the access points. So once you install this on your Android phone and open, when connected to Wi-Fi, you will see all these access points which are visible to your mobile phone. So I am connected to the first one, mobile WLAN. So you can see a lot of details here, and we'll explore those. So in the settings, you will see a time graph option. So this time graph option will actually allow you to plot the signal strength. So if you click on that, you should see something like this, a window like this, and you will see a lot of details. So on top, you will see the band to which you are connected, whether it is 2.4 gigahertz or 5 gigahertz. Then you will see signal strength in dBm and the frequency of the channel. These are important quantities for us. And on this plot, you will see several lines. You are looking at several lines here because these are the channels that are visible to the device. So we actually don't want to see all the plots. We just want to see the plot of the channel or the device that we are connected to. And this application allows us to filter out that frequency. So we'll come to that. So before that, here also you have interval scan setting where you can 1 second is optimum in all applications, in fact. So we have kept 1 second here for scan interval. And another important useful setting is keep screen on. So this will keep your mobile screen on for the duration of the experiment. Otherwise, in between the experiment, your mobile phone the screen may turn off, and you may have to disturb the setup. So this is an helpful setting. Then you can then to filter out the device that we want to connect to. The procedure is similar that we saw in previous applications. So we click on the filter option, which is on the top menu here. And this filter window will appear. Now in the SSID option, you enter the SSID of the device that you are connected to. That is basically the name of the device that you are connected to. So you have to type it as it is, and then when you apply, you will see the plot of you will see the curve only of the device that you are connected. Now, since here there are two devices with the same SSID, you are seeing a blue curve also, but the bold curve is the one that we are connected to. And again, you can allow the reading to settle down. It takes about 20 seconds or so for this application for the reading to settle down, and then you can take the measurement. So we found that this is one simple setup as compared to other setups. So if the other setups don't work, then this is one good option for all. And also there are other applications which give you the same capability, but they might have less features. The most important feature being the filtering option. Yeah, so that was for the Android app. Yeah, any questions?
Jyotirmay has raised his hand, so
yes.
Jyotirmay, do you have any doubts?
Yes. For the second experiment, suppose means we choose frequency equal to 2.4 gigahertz, then lambda will be suppose C by F. It is coming around 12.5 centimeter. So means, to carry out the experiment, so distance between the transmitter and the reflector, so that will vary up to 1 lambda or 2 lambda, 3 lambda for any lambda.
Yeah, as much as you can, in fact.
Not like that, only within 1 lambda or 2 lambda we have to take the reading, not like that.
So maybe you can go for less than a lambda also.
It will have to go in fine steps, much finer steps compared to lambda. Okay, in fact, you need a couple of samples even within quarter of a lambda to know the level of changes that occur on that separations.
Because lambda is coming here 12.5 centimeter, that means within 12.5 centimeter we have to take.
Yeah, so you might have to move by sort of 1/10 of the lambda at least. Okay.
Centimeter.
Initially, to sample the variations that might actually occur on those length scales.
So you can start with 1 centimeter and can gradually go to 3.
So typically 1 centimeter depth might reveal the truth better.
Yeah.
And reflector, suppose if we take aluminum reflector, or so it will work. Any
metal will work. Any metal will work.
Iron will also work. Iron.
Aluminum or metal, iron metal or copper or any. Even gold will also work if you put.
No, iron will also work. Iron. Loha.
Yeah, that also works.
Yeah, it will work. It will work, and based on its conductivity, there could be losses. Okay. Yes, it's like whether it's a good mirror or not at radio wavelengths.
Ayush has raised his hand. Ayush.
Can he unmute himself, or should we?
Yeah, just a second. I'm not able to unmute him.
Okay, I him to unmute. Yeah. Ayush, you should be able to unmute yourself. Yeah.
Hello.
Yeah.
Am I audible?
Yes.
Yeah, Ayush, go ahead.
So this was the experiment related to finding out the signal wavelength and the graph plotting of that network, right? What if we need to increase the signal strength? Is there any way to increase the signal strength of the network, or if we are using the mobile network directly, so is there any way to increase the signal strength from there and finding out the results then?
Yeah, we are not using the mobile network per se, in the sense not as given by the provider. We are using a local radiator, okay, created by the hotspot, or a router, okay, which is locally.
So we are using only router only.
Yeah.
So is there any way to increase the signal strength on the router?
Well, in a way, the second experiment is a recipe for increasing it by a certain factor, okay, and you will see the effect of it when there is a reflector behind, okay, in the forward direction, in the direction perpendicular to the reflector, you will indeed have more power than you had earlier.
Since we have observed this thing I have used many routers, and I encountered this issue that they provide us 30 to 50 Mbps, and we get 5 Mbps of sort of speed, and then suddenly it decreases to 600 to 700 kbps. So I was wondering if I could test that strength and find out if I could increase the signal strength as well.
Yeah. So there are two things. The aspects that you mentioned, where the speeds were mentioned, they have little to do with the signal strength. Of course, the communication will be poorer when the signal level is low, but the speed has got to do with the rate at which data are getting transmitted. And of course, you need good communication, that means good signal strength. But the rates might depend on the busyness of the network and so on and so forth. Okay? So there might be other issues dictating the speeds.
No, but the distance between the receiver and the transmitter is same, and there is no changes in the environment or the weather. There is no changes in the connection line with the router with the network provider. So there is no factors affecting the signal strength. So how could that decrease?
No. So that's what I'm saying. The rate at which data are transmitted, or any particular data download that you're doing, and at what speed that is occurring, it depends on the bandwidth that is allowed for you to download. Okay, but there could be other competing downloads going on. So that has got nothing to do with the signal strength directly. Okay, just by increasing the signal strength by a factor of 2, you're not going to change your speed of download.
So how can I do that?
These are unconnected things. Okay, so speed of download, of course, one of the ways people do that is to choose if they have this, if both the devices or the respective devices can work at higher frequencies by setting 5 gigahertz operation, it allows wider bandwidth. And so the downloads
will give the constant bandwidth, and the network speed would be stable if we are using the 5 gigahertz network.
Yeah, 5 gigahertz people use for faster communication.
Okay.
But please do not confuse that with the signal strength. You can have good signal strength, but not enough bandwidth allocated to you, where your data download speeds are still low.
Also, is it vary from different website to website, or is it related to the service provider only? The change in the bandwidth and the network signal.
Yeah, that I do not know. What that depends on basically the channel as a whole. Many segments might be contributing to the net speed you actually get. It's not just your end of the equipment.
Okay, Abhijit has raised his hand.
Yeah, you should be able to unmute yourself, Abhishek.
Hello, good afternoon. I have a really, maybe it's a very silly thing to ask, but one confusion I have. While doing the experiment, we'll have to put the mobile phone in the aeroplane mode. That means we should disconnect the phone from all this internet service, right?
Yes.
Yes, that's the suggestion, so that there is.
No, that means when I switch on the hotspot, the mobile becomes a source of this. It becomes a source.
Yes, absolutely.
I mean, even without the internet connection, is it?
Yes. Yes. Okay, it will be radiating a steady wave. It will not be radiating any information because there is nothing connected, no information to transmit, but the single tone might be getting transmitted.
Okay.
That is the hope. Some hardware allow that. In certain systems, unless the data is on or unless it's in non-flight mode, the hotspot itself is not allowed. In which case, you live with that situation.
In that case, I'll have to disconnect the thing,
no? You ideally want to disconnect it from the outside world so that the activity relating to the outside world doesn't affect your signal strength, or and then you if you cannot do that, and if you have to use a non-flight mode to have the hotspot on, then you continue with it, but just make sure that you're not heavily downloading anything. You're not doing any big data activity.
Yeah, of course. Thank you.
Thanks.
Abhijit, another Abhijit has.
Yeah, Abhijit. Yeah. So let's see.
Talukar.
Okay, so let me see if I can. Okay, you should be able to unmute yourself.
Sir, am I audible, sir?
Yes.
Sir, basically, I am using Linux. So I have a question regarding that. What I have done there is a copy of the file, sir, you have shown us. I think there is a IPYNB file in there. Yeah. So I have downloaded the file and I think I have imported that file into VS Code. I use VS Code for my coding. But I think
what do you use? VS Code?
Yes, sir.
Oh, VS Code. Okay.
So basically, when I try to run any of the, there are some tabs in here, but I am getting some errors. So is it necessary to install the Jupyter notebook, like some Anaconda or something like that, in order to run that notebook itself?
you will need to install Jupyter library. Anaconda is different. That's for managing different versions in parallel, creating an environment essentially.
I need.
Have you used Jupyter notebooks before?
Yeah, I have used, but I don't use it often.
And it works on VS Code properly?
Yeah, it works. So I can actually choose the Python interpreter as Jupyter notebook, so it should work fine.
Okay, if it has worked before, then you'll have to see what specific error it's generating. Most of this is going to be a generic Python related error, not necessarily due to this code.
Yes,
so I mean, either you can Google it, specifically that error, and try to see where you're going wrong. If the error is specifically inside the code, then I mean, either you let me know right now or post it in one of the forums, and I can try to have a look.
Yes. So I'll maybe actually Jupyter notebook is not installed on this device, so maybe I'll try to do that and then try to run
it. How were you able to run it earlier?
Yes, sir. So I basically didn't know. I thought that any any editor or compiler could do that, so I went for it.
No, editor is fine. It just matters whether Jupyter is installed on your system. The editor is just going to use what is installed on your system. VS Code does not require a separate installation of Jupyter.
Yes, sir. Okay, thank you, sir.
Okay, I have a general comment to make. Please don't feel discouraged at all if any one of the softwares relating to plotting or facilities related to plotting don't get installed or run properly. In these two experiments, you will notice that you require typically 10 to 12 measurements to be done in judiciously in terms of the distances or things to be varied. And those you should be able to get with essential tools that have been described to you, where you get the the signal level. So even if you're not able to plot it using the tools that are already described within those packages, you can, if you can note down those values and even plot it by hand, you should be able to get the gist of the behavior that you're looking for. Thank you.
I just wanted to make a comment regarding WizTumbler. So after installation, once you start the software, every time you start the WizTumbler, it might prompt you to update the software. So we recommend not to update the software once you have installed for the duration of the experiment. And some people had this problem that the antivirus was detecting WizTumbler as a malware and removing it. So you can either disable the antivirus or you can add WizTumbler as an exception in the antivirus exceptions list. So that should solve the problem.
Okay, so if there are no more questions, we can stop for today. And please do perform this experiment, and we'll see if you have any problem or anything, you can ask or you can raise your doubts in both the platform PBWorks as well as on Moodle platform, and we'll discuss next week. Desh, anything you want to add?
No, I think you've done well. So thank you.
Ashish, Prakash?
No, that's it from my side.
No, everything is good.
Ayush has
a question. Yeah.
Newer question. Okay.
Sorry, Desh?
Yeah. Ayush, are you there?
Hello. Am I audible?
Yeah. Go ahead.
So yeah, I have one more doubt. Like, if we need to perform this experiment using this particular software only, is it possible to connect to a router or to a transmitter with a secured connection? And if we do not want to connect that particular router or that connection, then can we perform this experiment? Then can the receiver will be connected using this experiment?
It might be possible. Some softwares do allow you to monitor all the packets that are in the basically collected by the device, but it may be only in certain softwares like in Wireshark, where we were able to see. In fact, even on the Android phone, you were able to see all the available channels except the Linux one. So I think
we are unable to connect those without the password.
So if you don't connect to that device, your device may not be listening to all the packets between your device and that device. So you may be missing a lot of. You may have to wait for some time to get a next packet and then get a reading on your power. So if you are connected to the device, there are basically certain packets, beacon packets that are constantly sent by both the devices.
Okay.
And if you are not connected, then you may lose connection in between, or you may lose the power tracking in between.
Okay. So I have to be patient in order to have a connection using this experiment. Hello?
Yeah, sorry, you're not audible.
I'm saying that I have to be patient in cases of the disconnection or temporary disconnection. I have to be patient to stay on the network so that it could perform experiment.
Ayush, your
voice is not clear.
Yeah.
Am I audible now?
Maybe you can type the question.
Okay, I'll type it. One more thing, that we were using the iron plate or any other metal plate. So will that work with the concrete as well?
You can use metal plates.
Concrete will not work.
You can try, but and you can try and see what effect it has. It will certainly have different reflectivity.
What is the question? What other plates?
I'm saying concrete or stones. If we are
concrete or stones.
Yeah, it will have some reflectivity. It depends on whether it's reinforced, but it may not be as clean as the metal.
Okay. I see. Thank you.
Okay, if there are no doubts or anything, then we can stop for today. We'll meet next week again.
So thanks everyone.
Thank you everyone. Thank you everyone.
Bye.
Yeah, thank you all.
Okay. Bye guys. Take care. Sagar, you can stop the recording and you can close for the session.